Well, hi guys. Here we're going to have a look at this idea of really finding the equation of a tangent to a curve, as it says in the heading up there. So what we're going to have is a situation where you're asked to basically find the equation of a tangent to a, say, some function like this one here. So what we've got is some curve, and we've got a point, and what we're asked to do is to find the equation of the tangent, and sometimes also the equation of the normal to this curve here. So one of the key ideas that's important here is that, excuse me, one of the important ideas here is that if we have a curve, obviously we've got points on that curve, and the gradient is changing, okay, as we go to different points along the curve. And the idea of the tangent is that at this point A, say, if I draw this green tangent line in here, well, the gradient of the tangent, that gradient of that green straight line, is equal to the gradient of the curve at this point. So let's just make a note of that, that the gradient of the curve at A is equal to the gradient of the tangent at A. Now, we know how to find the gradient. One of the central ideas of differentiation is that the derivative of the curve at A, when you substitute, say, an x value into that derivative, well, it equals the gradient. So this is another key idea, second key idea here, that the gradient at A is equal to the derivative at A, okay, when we substitute x in. So to find the equation of the tangent, let's not also forget that a tangent is a straight line. Sorry guys, I must be pressing some key on this tablet I'm using by accident. Okay, so here's the general straight line equation. And just very quickly again, if you're not sure where that's coming from, okay, excuse me. Okay, if we have a straight line and we get a couple of points on that straight line, goodness knows what I'm doing, guys. I'll try and hold the pen in a different position. That might help. Or not. Okay, so let's say we've got a point here, let's call it A, and another point here, let's call it B, and let's call this point here X, Y, and let's call this point here B, X1, Y1. And if I want to find the gradient between A and B, go away keyboard. Okay, what we need is the change in Y over the change in X, as you should be well aware of. So the gradient, which is equal to the change in Y over the change in X. Okay, the change in Y, well, that's the difference in Y values here. So I can go this Y value, which is Y, minus this Y value, which is Y1. That's the change in Y. And the change in X would be X for this X value here. And then take away this x1 value, and that will give me this distance between them here. Okay, so x minus x1. Now, if you do a simple cross multiplying here, because this is over 1, we get y minus y1 equals m bracket x minus x1. And that's where that general straight line equation comes from. Okay, so let's see how we can find the gradient of the tangent at a point. And I think what we need is an example. Let me just get this eraser a bit larger. Come on, keyboard, go away. Did I change that? Yes, I did. What the heck am I doing? I must be doing something wrong here with that keyboard. Okay, so let's take an example. Right, so let me grab a question from somewhere that we can use. Okay, so let's say we're asked to, as an example, find the equation, let me abbreviate equation to that, of the tangent to the curve, and let's use y equals x squared minus the natural log of x. Okay. When x equals 1. Okay, so to do that, okay, what we're going to need to get are two things. Okay, we need to find this equation, and to find that equation, here's the two things we need. A, we need the gradient. What is the gradient? Secondly, we need to know what is x1, y1, because we need to substitute those things into here. Well, let's deal with the x1, y1 actually first. What we've got is x equals 1, and we've got an equation that links x and y, so we're simply going to substitute. Okay, so we're going to have 1 squared y, because x is 1, minus the natural log of 1. Now, you can check for yourself, but the natural log of 1 is 0, so we get y is 1 squared, or 1. So our point, our x1, y1 point, okay, let me just emphasize that, x1, y1 is 1, 1. Okay, how do we find the gradient? Well, the gradient, okay, we're going to use the derivative to get that. Okay, so let's derive. So the derivative, dy over dx, or y dash. Okay, so we're deriving this function here. That'll be 2x, because the power rule applies to this bit. What's the derivative of a basic natural log? That's right, it's 1 over x, so minus 1 over x. And if x equals 1, because we're interested in when x equals 1 here, okay, then the derivative would equal 2 times 1 minus 1 over 1. Okay, so that's going to be 2 take away 1, which is 1. And let me put this in a different color over here. Okay, so the equation of the tangent, y minus, so substituting into this thing here, y minus 1, remember that's this x1, y1 we're substituting in, and the gradient also happens to be 1 in this case, so x minus 1, so a whole lot of 1's there, and yes, we can make that a little simpler. Okay, 1 times this is just x minus 1, and we could put it in the form y equals x minus 1, and that's going to become plus 1. Y equals x in this case is our equation of our tangent. Now, don't expect this cancellation to happen in every question. The other way that you quite commonly see the answers in the back of the book is that they bring x and y and the numbers to one side and make it equal 0. So let me do that. So let me just highlight where I am doing some slightly different work. So I'm going to have y, no, in fact, no, I'm not going to do y because I want to get the x positive, so I'm going to bring everything to the right hand side. So on the right hand side I've got x minus 1, I'll move the y over and I'll move this 1 over and that will equal 0, okay, which was left on the left hand side. Okay, and yeah, the 1's cancel, so you just get x minus y equals 0. And of course you could have made that same equation from this step here. Okay, so that's one example. Let's have a look at another example. So I'm just going to pause the video to get a clean page up here. Okay, so let's have a look at a second example. Okay, so let's deal with this idea of normal at the same time. Okay, so if we've got, once again, a curve, and we've got a point here, okay, and then I draw a straight line, a tangent. Let's get that in that green color again. Okay, in fact that's not a straight line, but that'll, no, it won't do. Let's Control Z that. Let's try and get that line in. Here we go, that's a bit better. Rightio. Now this here, as hopefully you're well aware now, is our tangent. Now, what's the idea of a normal line? Well, a normal line is a line which is at right angles to this one. So let's see if I can actually draw that in. That's not too bad. Okay, so let's go back to not drawing a line anymore. Okay, so what I want to do is just indicate that these two lines here are at right angles to each other. Now there's an important property of lines which are at right angles to one another, and that is something about their gradients and what they multiply to. Okay, let's say for example that this black line here, this tangent line, and let's put a label in for this one, this is the normal line. Okay, if we got some values for the gradient, let's say that the gradient of this tangent was equal to a half. Now what you'd find for the normal, and you just have to believe me that this would be true, that the gradient of the normal, okay, and I'm going to indicate that with an upside down t, and that upside down t means perpendicular to, because this is a right angle between these. So this is the symbol without the little right angle symbol there. This is the symbol for perpendicular, i.e. at right angles to each other. Okay, in fact, let's rub that out, don't need that anymore, but that's what that symbol is. Oh, come on, erase for me. Yes, there we go. Alright, so what we've got is that the gradient of this normal would be negative 2. And one thing I'd like you to notice is that if you multiply the half with the negative 2, you get negative 1. And this is true in general, that when you take the gradient of a tangent and multiply it with the gradient of the normal, it always equals negative 1. And we can look at a few further maybe even a proof of that in class time, but we'll accept it for now. So let's use this idea and look at a question where we might be asked to find the equation of the normal. Okay, so let's take this example. Come on, erase. So find the equation of the normal to the curve y equals, and we'll do a trig function here, 3 sine 2x at x equals, and we'll have this value pi over 4, a fraction of pi. Right, so what's the key steps here again? Well, the equation of a normal is still a straight line. So it's y minus y1 equals, and I'll put here y perpendicular, x minus x1, just to remind us that this gradient is the one which is going to be perpendicular to the gradient of the tangent. Okay, so why do we need the gradient of the tangent? Because when you derive and you substitute in pi over 4, you're getting the gradient of the tangent. So let's do that. So we're going to derive, and it's a trig function, it's a sine one, it's also composite. So what's the basic derivative of a sine function? Okay, you should be memorizing some of these by now. It is cosine x. And if you have a composite function, we would get 3 cosine 2x, which I'll put in brackets just to make the substitution clearer in a minute, but then times the derivative of the inner part here, which is 2. So let's simplify this, 6 cosine 2x. Now, I need to get the gradient of this perpendicular line, this normal, but the gradient of the tangent would equal 6 cos, and let's substitute in this pi over 4 now, so 2 times pi over 4, and that's equal to 6 times the cosine, or the 2 and the 4 simplify a bit, to pi over 2. Now, what's the cosine of pi over 2? That's actually going to come out to be annoyingly 0, I think. If you look at the cosine graph at pi over 2, the cosine is 0, so our gradient of this one comes out to be 0, which is a bit annoying because I actually didn't want to have that to be 0 there. So I'm going to change this question just to make this something which is more like the questions you're likely to get in a real exam situation. I'm going to make that pi over 2. Okay, so let's change this here. Let's change all this. Okay, where is my pen? There it is. So it'd be 6 times the cosine of 2 times pi over 2, and this time this will be 6 times the cosine of pi. And the cosine of pi, plug it into your calculator, or even better, know your cosine graph, and that is pi there, so this would be -1. So this gradient would be -6, because we get 6 times -1. So that's the gradient, and I'll put here a reminder that this is the gradient of the tangent. So what would the gradient of the normal be? Well, what you'd have to get the gradient of the normal, just follow on from there, is that the gradient of the normal would equal -1 over the gradient of the tangent. If you move m over to the right hand side, okay, so that's going to give, in this case, -1 over -6, or 1/6. Okay, now if we're going to substitute into this here, okay, I've got the gradient of the normal now, but I also need x1 and y1, and I've got x here, pi over 2 now, so I need to calculate what y is. So let's do that over here on the right hand side. And let's put that in black. So y would equal 3 times the sine of 2 times pi over 2, and that would be 3 times the sine of pi. Okay, and what's the sine of pi? Well, that's actually going to come out to 0, which I don't mind too much for this question, so that is pi there. So plug this into your calculator, or once again, better if you know your sine graph, the sine of pi is 0, so this will be y equals 0. So let's get the equation of the normal, finish this off, equals, or is, y minus 0, that's the y1 value, equals the gradient of our normal, 1/6 bracket x minus our x value here, pi over 2. So this simplifies to 1/6 x minus pi over 12. Now, yeah, in the back of the book, you won't see the answer written like this. If this was the exam, okay, this will be fine. You could leave it like this. What you could also do, as a bit of practice, is to get it into the form which you see in the back of the book, which is this kind of form here, where you have a coefficient x, a coefficient y, some constant, which is not written like that, plus c equal to 0. So if I wanted to get it in that form, what I could do is I could multiply everything by 12. Okay, so if I multiplied everything by 12, okay, what would I get? I'd get 12y equals, now 12 times 1/6 is 2, so I get 2x, and pi over 12 times 12 is minus pi. And if I bring everything to one side, keeping the x positive, I have 2x minus 12y minus pi equals 0. So this is fine, okay, no problem with that. This is probably what you'll see in the back of the book for this type of question, and this is how we're going from this form to this form here. Okay, that'll do. So what we'll do in class, guys, we'll have a look at a few other questions of this type and get you to do a bit of practice. So catch you in class.